Hey guys, this is question MM099 from the Maths Methods Sharpened Study Guide. The function g of x is given by g of x equals ax squared plus bx plus c, where a, b, and c are real numbers. The function g of x passes through the point 2, 28, so this is very, very important. Has a turning point at x equals negative 5 on 4, and has a gradient of 2 at x equals negative 1. So gradient of 2, x equals negative 1. Find the equation of the function g of x. Awesome. So let's start by just rewriting the equation. So we've got g of x equals ax squared plus bx plus c. Basically, our objective is to find out what those three coefficients are. Awesome. So the first thing that we get is the point 228, which we could sub in now, although this is going to leave us with three different variables in the equation, and it's not really going to help us that much now. So I'm just going to skip using this for now and go straight to the turning point at x equals negative 5 on 4. And as you do more of these questions, you'll sort of see which sort of method you have to do to make this happen. But let's start with that. So we know that the x value of a turning point is given by negative b over 2a. We also know that the turning point occurs at x equals negative 5 on 4. So negative 5 on 4 is equal to negative b over 2a. Now what that means is, if we multiply this out, we get negative 10a times both sides by 2a, and 4 times negative b is negative 4b, which means that b is equal to, if you divide both sides by negative 4, you get 5 on 2a, which means that g of x is equal to ax squared plus 5 on 2a x plus c. So all we've done there is replace that b with what it is in terms of a. So then we only have two variables. We've only got a and c. So that's our first sort of equation, I guess. The next part, so we've now used that turning point, and we know that it has a gradient of 2 at x equals negative 1. So that means that the derivative of x equals equals 2 at x equals negative 1, which means that f dash of negative 1 equals 2. And if you haven't done your differentiation component by now, maybe watch this and just see how I do this. But if you have done it, awesome, just keep going. So what is the derivative of f of x? Oh, sorry, this should be g of x, my bad. G of x, g dash of x. Awesome, so we know that g of x equals ax squared plus 5 on 2ax plus c. We want to find out what g dash x is. So as with all differentiation, we take the top power, take it to the front, and then minus 1 off the power. So this becomes 2ax, and then this part here, because this is an x to the power of 1, we just cancel that out and it becomes 5 on 2a. So plus 5 on 2a, and c is a constant, so that just becomes 0. So g dash of x equals 2ax plus 5 on 2a. And then from here, all we need to do is sub in 2 and negative 1. So 2 is equal to 2a times negative 1 plus 5 on 2a. And where we go from there is we've got only a's and numbers, so we can actually work out what a is from here. So we have negative 2a plus 5 on 2a. Negative 2a is the same as negative 4 on 2a plus 5 on 2a, which is equal to 1/2 a, 2. Dividing both sides by half, we get a equals 4. So we know what a is now, which is equal to 4. And since we know that b is equal to 5 on 2a, and we know that a is 4, b equals 5 on 2 times 4, which is equal to 5 times 4, which is 20, over 2, which is 10. So b equals 10. Fantastic. Now all we need to do is work out what c is. So let's rewrite the equation with a and b chucked in there. So we know that g of x is equal to 4x squared plus 10x plus c. And now is the time when we want to use this 228 point. So we sub in 28 for y and 2 for x. 10 times 2 plus c. And then we can see we've only got c and numbers here. So 4 times 2 squared is 16 plus 20 plus c equals 28. 28 take away 20 is 8. And then 8 take away 16 is negative 8. So c is equal to negative 8. Awesome. So we know what a is, we know what b is, and we know what c is, which means we can now rewrite our final equation. Remember, it all depends on what the question's asking for. this question is not asking for the values of a, b, and c. It's asking for the equation of the function g of x, which means our final answer needs to be g of x is equal to 4x squared plus 10x take away 8. And that is our final answer. Part B, express g of x in the form a times x plus b plus root c over d times x plus b take root c over d, where a, b, c, and d are positive real numbers. So this might look complex to start with, but all we need to do is, let's just start by rewriting our original equation, which was 4x, sorry guys, 4x squared plus 10x take 8. That was our original function. So I can sort of recognize, and you will too after a bit of time doing these sort of questions, is that this is found by completing the square. So the only way that we complete the square, or that we can complete the square, is if the coefficient of x squared is 1. So the way that we need to do that is take out a common factor of 4. So it becomes 4 x squared plus something x. And we need to figure out what is, like, it's sort of like, what do we need to times by 4 to get to 10? And it's 2.5, which is 5 on 2. So this becomes 5 on 2x. And what I mean by that is 4 times 5 on 2 is equal to 10. Take away 2. So this is our sort of, I guess, factorized form in a way. And we need to start completing the square. So in order to complete the square, we take our middle factor. So we write the two first ones, and we just keep this 4 out here for now, and we'll bring that in later. For now, we halve the middle coefficient and we square it. So half of 5 on 2 is 5 on 4, which means that this is equal to plus 5 on 4 squared. And then we have our negative 2 on the end. And then we take away 5 on 4 squared. And that's all times 4. But we'll wait until we sort of bring in the 4 later. Awesome. So from here, we know that x squared plus 5 on 2x plus 5 on 4 squared is a perfect square because of the way that we've done that. So this is equal to x plus 5 on 4 all squared. So that's the way that this is sort of like by itself here, that expands or factorizes to x plus 5 on 4 squared. And then we have a take away 2 take 25 on 16 at the end. And again, all times 4. So we have 4 x plus 5 on 4 squared. And then we have take away 32 on 16, take 25 on 16. And I've just done that to make it easier to add the fractions together. Now negative 32 take away 25 is negative 57. And where to from here? So basically what we need to do from here is get it in this form. And how we do that is by making this term into a square. And what I mean by that is 57 on 16. Actually, let's rewrite this for now. Because we want to create a difference of 2 squares here in order to get these sort of brackets. And the way that we do that is making this second term into a square. So what do we have to put in here that is squared to make it equal 57 on 16? And the answer is root 57 over square root of 16, which is 4. So the square root of 57 on 4 squared is the same as 57 on 16. So this is basically what you need to do. You need to square root the whole thing and then put it in a square bracket. And the reason why is because now this is a difference of 2 squares, which is where you've got, x squared take y squared is equal to x plus y, x take y. And that's sort of the jump that we're going to make here. So in this case, this part here is our x, and this part here is our y, and we're going to put them into these brackets here. So we've still got this 4 out the front, don't forget to write that. But now we've got x plus 5 on 4 which is our regular x, and then our y is root 57 on 4. So we go plus root 57 on 4, bracket, and then we have another bracket, which is our x, which is x plus 5 on 4, and then our y value, we're minusing this time. So we got minus root 57 on 4. So we're starting to get to the point where we can actually see this form taking shape. So no longer do we need these square brackets, we can just keep using the circle brackets. And all we need to do now is merge these two fractions together. So we've got 4x plus 5 plus root 57 over 4, because these two are the same denominator, so we can join them together, times x plus 5 take root 57 over 4. And we've actually gotten to the final answer here. So we've got it in the form a, which is 4, x plus b plus root c over d, which is b plus root c over d, times x plus b take root c over d. And this is actually our final answer. So this question is worth 3 marks. And our third mark is here. Our first mark is recognizing that we have to complete the square and getting it into that form. So this is your first mark here. And then your second mark occurs when you have to recognize to do the completing the square. So your second mark sort of occurs from the jump, from here to here. So around there is your second mark, and then your final answer is the third mark. And that's it. Part C, we need to find all values of x for which g of x equals 0. So because of our previous question, we know that g of x is equal to 4 times x plus 5 plus root 57 on 4, side of x plus 5 take root 57 on 4. Awesome. And we need to find all the values of x for which g of x equals 0. So we basically sub 0 into this. We get 4 x plus 5 plus root 57 on 4, side of x plus 5 take root 57 on 4. I know this is a pain to write, but you'll get used to it. Divide both sides by 4, that cancels out, and 0 divided by 4 is still 0, so that just remains the same. Because of our null factor law, we can say that both of these brackets are equal to 0, which means that x plus 5 plus root 57 on 4 is equal to 0, and x plus 5 take root 57 is equal to 4. Sorry, over 4 is equal to 0. Which means that x equals negative 5 plus root 57 over 4, and x equals negative 5 take root 57 over 4. So this is literally your final answer. It is sort of a simple question, but I think it's more the concept that is difficult to grasp. So all you've got to do is sub in 0 for g of x, and then solve for x basically using the null factor law, which is sort of easy in this context. Just try not to make any errors here, and try not to make it more complex than it actually is, because it is quite simple as you've seen here. So that's your final answer.